Okay, let's find the derivative dy dx using implicit differentiation on this problem. So we're given a nice equation, got three terms going on here. Let's jump right into it. So as we take a look at this, on the left-hand side, we're just going to use the power rule, right? We have y squared, so we can bring the exponent down in front and reduce the exponent by 1. So 2 minus 1 makes 1 for our new exponent. But in this case, remember that our variable was y, so we need to include a dy dx being multiplied with this. We're taking the derivative with respect to x. Okay, on the right-hand side, one term at a time, we have negative 10y. That's a nice linear term, so we could think of it as the power rule, or you can just remember linear terms, it's going to be basically the number in front, kind of like the slope if we were dealing with a line. Again, we have a y as our variable, so we need to include a dy dx with this. We're taking the derivative with respect to x. And then finally, our last term here, we have negative 8x. So another linear term, we're going to get the negative 8. Now, your variable here was x. We could put dx, but we hardly ever do that, right? Because when we have a dx, that's the same thing, numerator and denominator, that makes a 1. And writing negative 8 multiplied by 1 doesn't really make a whole lot of sense. It doesn't move this problem forward very much, so we typically leave this off. All right, from here, we have dy dx's on each side of our equation. The end goal is to get those on one side all by themselves. So what I'm going to suggest next is we're going to go ahead and move them all to one side. So to do that, what I'm going to do is move them to the left-hand side because we have a constant over on the right-hand side. So we want to add 10 dy dx to each side. All right, we did it on the right side. We're going to have to add 10 dy dx on the left side. All right, on the right-hand side, negative and positive, right? Subtracting and adding the same thing makes 0 dy dx's. So on the right-hand side, we will be left with negative 8. On the left-hand side, you can write these in either order. I'm going to go ahead and say 2y dy dx plus 10 dy dx. All right, and you'll notice the same kind of trend goes on with a lot of these. After you get the dy dx's all on one side, now each of those terms has one of them, so that means that that goes as a common factor. Now, I agree, it's not the greatest common factor between those two terms, but we're going to go ahead and just factor out the dy dx. And what that's going to leave us with is we need a 2y plus 10 inside that set of parentheses. All right, so if you redistributed the dy dx to each term, you'd get back the same line as you had previously. All right, all that remains here is to isolate the dy dx. Well, we've set ourselves up so that it's that multiplied by the set of parentheses. So we're next going to divide both sides by what was inside our set of parentheses. So divide both sides in our case by 2y plus 10. This will mean that we have the same factor in the numerator and denominator, which makes a 1 over on the left-hand side. And that'll put the dy dx on the left-hand side all by itself. And it's going to equal, in our case, this negative 8 over 2y plus 10. So that's our derivative for this function using implicit differentiation. Hope this helps out. Good luck.